The following is a demonstration of the work done for my graduation. What I've created is a modular integration of the PhysX physics engine for the Rice game engine. Through this graduation, I've integrated the following features: Rigidbody Dynamics, character controllers, collision filtering, and scene queries. First, we will see these features in action within the Rice engine. The following is a brief demonstration of the API for each of the physics features previously presented. For Rigidbody Dynamics, after creating an entity, we can add a physics component to this object. Using this physics object, a user can then add colliders to it. Doing so will create a static physics object. A user can then turn this object into a dynamic object by adding a rigid body component. Using this component, properties such as velocity, mass, and drag can be modified. For character controllers, after creating an entity, a capsule controller component can be added to this object. We can then modify the properties of the character, such as its height and radius. After doing this, a user can then add certain features to this object, such as gravity and rigid body feedback. This can be done by using the preset system. The user instantiates the preset and adds it into the capsule component. The idea is that the logic of handling the preset is left to the active physics engine. For collision filtering, after adding a capsule controller or a physics component, we can modify how it interacts with other objects. Using the example of the collision filtering demo, we have the third cuboid that blocks all objects. In this case, we don't have to do anything because that is the default behavior. The second object, which overlaps character controllers and dynamic objects, can be created by calling the setAllColliderReactionToObject function. As seen in the image, a user can set the object to react to character controllers and dynamics by overlapping them. The next object blocks character controllers but overlaps dynamics. This can be done by calling the setAllColliderReactionToObject function, so that the object reacts to character controllers by overlapping it. In order to be notified of the collision events generated from these objects, we can bind functions to the collision events. We receive the events as a parameter and can act accordingly. There are 3 collision events: onTrigger enter, onTrigger stay, and onTrigger exit. All collision events contain the pair of entities that triggered the event. For scene queries, all scene queries can be accessed using the static functions provided by the physics helper class. When doing a raycast, after specifying the start, direction, and length of the ray, we can specify a query hit object that will contain the entities that overlap or block the ray. With this information, we essentially get the default ray, which will be blocked by any object regardless of its mask. In order to control how the ray interacts with different masks, we can specify a query mask. We can then use it to modify how the object interacts with a certain mask. In the image above, we have a weapon mask that blocks objects with a bulletproof mask and a brick wall mask, but overlaps objects with the glass mask. On the other hand, we have the visibility mask that overlaps the glass mask and bulletproof mask, but is blocked by the brick wall mask. Objects can be assigned to a mask as shown in the image above. The result is a raycasting system that can report different blocks and overlaps depending on the query mask set. The same system works for sweeps and overlaps, although in the case of overlaps, setting the reaction to block or overlap in the query mask would be the same thing.